That is something. Okay. Seems like I am live. Yep. Most probably am. Now, for today, Modern Assembly Language by Larry D. Pyeatt. Yesterday we were at about um where were we? We did Thirak. Thirak was a machine, and then yes, we were at exercise. We had to do questions. We had completed this. Now we have to begin with question number 5. Let's begin. And the goal is at least to complete all these exercises, which is just uh, uh, 7 questions. Given the following definition for a stack, ADT, this, okay, and this, write the init stack function in assembly 64, AArch64, okay. Type def, structure, int stack, okay, this is stack.h file, and here we make a pointer to this structure, type def into int stack, create an empty stack and return a pointer to it. Init stack is a, okay, here are just definitions for them. Pops takes in a stack, and pops init stack initiates returns a pointer to a stack, pointer to it, right? Push value onto the stack, return 1 for 6 is 0 if the stack is full. Okay, init stack take an integer, returns integer. Okay, return value from top of the stack by this stack.pop, return 1 for success, return 0 if the stack was empty. Okay, remove, this is to remove the value, return the value that is at the top of the stack, this function. Okay, print the elements of the stack. Extern, that is an external function called print stack extern. Okay, we will see it today in the other stream. Extern, what does this mean? In print stack, int stack, stack takes in a stack and prints the stack. Then we have stack.c. This is the file which is using these type definitions. In this, the stack is implemented as an array of items and the index of the stack is at top. And the index of stack is at the top. Structure, init stack structure, it has it has a array of 100 size integers, and stack items is the name, and top contains the top of the stack. Type def, we make type def structure init stack structure into int stack point, okay, pointer to this and int stack, right? Init stack function in AArch64 assembly. Okay, so this is the structure which we have to return from AArch64 assembly when this function is called. That is easy. That was obvious. And let's begin. I will move on to the folder where I write my assembly code and chapter 6.s. Okay, so first that we have to define it. We have to have an array of 100 elements. So an array of integers of 100 integers, and one integer takes 32 bits, that is 4 bytes. 4 bytes and 100 of them, therefore 400 bytes. So array will be an word, 100 words. Nah. space. And how many space do we need? 400 bytes. Yes, that would be our array. And we would also need an integer. So that would represent the top of the stack. So do we store that integer in memory? Yeah, yep. Index, we will call it index, and that would be a word, a single byte. Yep, a single byte would be enough for it. Byte that initially says 0. That is, initially the pointer index is at 0, the bottom of the stack. Then in the dot text section we say that we have a global thing called main, and we align, and then in the main function let's first declare the init stack, which does not take any output. It only returns a pointer to the stack. Yeah, it only returns a pointer to the stack. That is okay. So this has to get some storage. Ah, instead of statically storing this for a stack, I need dynamic memory allocation. And for dynamic memory allocation, I have to call malloc. And malloc returns a pointer, and the first argument that the malloc function takes in is the number of bytes that we need, which is 400. I have an incoming call from a random number, but that is okay. FBI is not after me. Now, we want to call malloc, and for that, shit, because we are calling a function, first we have to store the stack pointer, not the stack pointer, but not the stack pointer. We have to store the link contents of the link register, and store pair the frame pointer onto the stack like this by pre-incrementing the stack by getting 16 bytes of memory there. And then we will move into the 0th register the amount of storage the amount of bytes that we need, which is 400. And then we can just branch link to malloc, and then we can expect to have in the 0th register a pointer. Yes, a pointer, and we can just return that pointer. That would be crazy. We can just return share. That was all we had to do. Okay, and here we can also have .equ where array would mean 0. Array would mean 0, and .equ here here the index for integer, that would be no, not 400 bytes, but 400 plus, let's say, 8 bytes to also 400 bytes for the array, and 8 bytes. 8 bytes is a lot, and 4 bytes for the top of the array. And index and array would start from the fourth index after the 32 bytes for the top. Top would mean 0, and this should work. And then what can I do? In here, first of all, I will store the frame pointer and the link register onto the stack by pre-incrementing the stack. And then in the 0th register, I can get the pointer to stack after this, and do I write all the other function definitions to push? I've written init stack, and do I write push and pop and top? Okay, that is the next. These are the next questions. Referring to the previous question, write the push function in assembly language. Okay, push function which would push stuff onto the stack. Push function. This would expect a pointer to the stack in the first, in the 0th register, and in the first register, the index for not the index, but the number that is to be pushed on to the top of the stack. So what do we do here? Yes, we will move the value. And yes, malloc, we have to initialize the stack, right? We cannot just leave it empty. Yeah, I guess this is okay because when I'm mallocing, I can expect to see that the memory space that I get has zeros filled in it. So therefore, if I am pushing to a stack and I see the index in the first 4 bytes, I would see 0 in a new stack. Okay, move into the third register or second even register, the not move but load into the first 4 bytes of the second register the value whose address, the memory location whose address is in the 0th register. And then I have the index in the, god damn it, I have the index in the second register, and then the I can turn the index to the offset. How? I have to multiply it by 4. That is, and then add to it 4. 4. Why do I have to add to it 4? Because the array starts after 4 bytes. So yeah, I have to add to it 4 and add the offset. Mul add. No, it was like mod or something. Mod. Okay, wait. Multiply the contents of the second register and store them into the second register. Multiply them by 4. Or I can just do this. Add and save to the second register the contents of the second register plus, I just first, yeah, logically shift left the contents of the second register by 2. That is multiplying it by 4, and then add to the second register 4. Now I have the proper offset, and then I have the value in the first register which is supposed to be stored at the stack. So store the value of the first register at the address, at the address this. And after that I have to update, and I think I should get the offset in the third register, right? Yep, in the third register, so that I have the original top of the stack, and I can make change. I add 1 to that top and then store it back in the heap. Now I have stored the variable, the integer that was given to me to add at the top of the stack. Now I want to increase the top of the stack by 1. How do I do that? By adding to the second register the number 1, and after that I can store the contents of the second register at the place which stores the content, and then I can just it it returns with 0 if there were no error. Then move into the 0th register, 0, the value 0. Yep, that makes sense. Okay, so I have implemented the push function. It seems referring to previous two questions, right? Pop function in AArch64 assembly. And I'm not making any external call, so I do not have to store the stack pointer or anything. Now, pop, pop, for pop, what do we get? We only get a pointer to the stack. What can we do with it? First off, first of all, we would like to get the top index of the stack, which is the first thing in the stack. Uh, um, this plus top, top is the offset here, and instead of doing all of this, I can do top here and ARR here. Yeah, and yep. I get now in that second register, I have the index of the top of the stack. Then I would like to get the value. Nope, I would like to, I can just decrease the top by 1. That is essentially deleting the value. So subtract from the second register and store it into the second register, the value 1, and then store the contents of the second register at the top. Now the top is updated and I can just return. So pop was easy, and then after pop I have to write the top function. Top function, what does it expect? Takes in the pointer to that stack. Okay, what does this has to do? First of all, of course, I will get the index for the stack. Let's say in the secondary register like this, and then I would like to get the value that is stored at the top of the stack. How do I do that? I will first like to make this index into the actual offset, which has to be added to the base address, which should be first logically shift left and store in the third register the contents of second after logically left shifting them by 2, that is essentially multiplying them by 4, and then add to the third register and save to the third register the value of array. Yep, and then we can load into the which register, and then we can load, let's say, in the fourth register the contents that are stored at the top. Yep, and then what do we have to do? We got the contents, we have to now reduce the index, reduce the top index by 1, that is subtract from w2 1, and now store w2, the new index, at the stack. Yes, and then Yes, and then just move the value, the return value, that is the top element which is in the fourth register, into the zeroth register. And wait, first I have to move to the entire zeroth register the value 0, and then do this, and then just return with that. Yep, that seems to be correct. And then referring to the previous three questions, write the print stack function in AArch64 assembly which prints the top of the stack. That is crazy. Print print stack. The first argument is the pointer to the stack, the base of the stack. Now, first of all, like always, we will get the index in the secondary register from the base of the stack. Right, after getting the index, we will initialize a counter which will go from 0 till the top of the stack, and it will keep printing. Nah, but I would like to have the top of the stack start printing from the top of the stack and till down. It's okay. Hmm. Okay, I will start from the top of the stack and keep printing downwards. So for this, I would also need something like in the dot data section, I would need a format string, which is an ASCII's value, and the value is %dn, 1 digit per line. So what do I want? Yes, I will be calling the printf function from this. So I should save the frame register and the linker register onto the stack, onto the like actual processor's stack. Store pair the frame register and the linker register at the stack by pre in decrementing it by 16, and then I get the index of the top of the stack in our stack little stack thingy. Then what do I want to do? I want to get the value at the top of the stack, at the index, and then decrement the index. So is this it? I will initialize a loop which expects I should store this value in a non-volatile register. So move, I can just use it here like that, and also store the contents of the 19th register onto the stack before actually doing something with them. SP and minus 16 pre-increment, store the contents there, then use the 19th register for my work by storing, by getting the index in the 19th register. Yeah, now I have the index of the top of the stack in the 19th register, and I want to get the string, the format string to pass on. Now I want to print something, but that this will be a post test loop, therefore I will test later. Here will come the body, and at the end I will be comparing the 19th register contents with 0, and I want to go till 0. So branch if equal or greater than equal, if the contents of the 19th register are greater than or equal to 0, then branch to the loop. That makes sense. This will keep the loop going, and for end subtract from the 19th register 1, and here what do I do here? Hmm. First I would like to have the address of the string. Yes, I have to remember. Yes, I want some place where I can store the address on the top of the stack. Shit. Address from the pointer to the stack. So I should, instead of just storing the 19th register, I will also store the contents of the 20th register. Yep. And then move to the 20th register the address of the base of the stack. And here I can just get the address of the format string by first getting the page address for the format and then adding to it the page offset. Okay, now in the 0th register I have the address for the string, the first argument to the printf function. Now at the top of the stack I want to push the value that is at the top of the stack, the value that is at the top of my own stack which I created. So for that I would like to have some space at the stack, let's say 16 bytes, and then what would the offset be? I know that I have the index in the 19th register and the base address in the 20th register. So let me calculate the offset in the first register. So I logically shift left the 19th register contents, no, save them in the first register, the contents of the 19th register, by logically left shifting them by 2, that is multiplying by them by 2, and then add to it to the first register the offset for array, and also store them there like that. What else? Now I have the offset. Now I should add that offset to the base address by adding and saving to the first register the contents of the first register and the 20th register. 20th register here has the base address and the first has the offset for the current element of the array. Now I will load the value at the top of the stack into the first register, and the address I know is in the first register for that memory location. And here, after getting that, I will store it to the top of the stack. So str the contents of the first register at the top of the stack, and then I can just call the printf function, right? In the 0th register, here I have the address of the format string. In the first register, I have the at the top of the stack, I have the value that is to be printed by the printf function, and after that I subtract 1 from the index, and then I go back to the loop, get the address again, and get the next value and print that. That should actually do it. So after the loop, yep, after the loop. After the loop, what happens after the loop? I have to free up the space that I used on the stack. This function does not return anything, so that is cool. After the loop, I will add to the stack pointer the 16 bytes that I used, and then load the 19th and the 20th register contents from the stack, and then load back the frame pointer and the link register contents, and then move into the zeroth register 0, and then just return, which this should actually work. I don't know, this should work. I have implemented it. Now re-implement all of the previous stack functions using a list rather than a static array. That is doable. That is doable. Okay. First of all, let us check if it actually works. What do I have to do? First, I have to initialize a stack. So branch link to init stack. Now I have in the 0th register the stack, the pointer to the stack that I just got. And I would like to store it into a non-volatile register by storing storing the contents of the 19th register at the top of the stack by pre-incrementing and decrementing the stack by 16, and then I can just move into the 19th register the contents, the pointer from the 0th register. Then I would like to push, before push, I would like to give the value in the first register which I want to add to the stack. That value should be, let's say, 1, and then I can branch link to push. Yep, and after that I have to repeat the same by moving into the first register the value that I want to push now, and also moving into the 0th register the stack pointer from the 19th register, and then branch link to push, and copy this and do this a couple of times. Okay, and then 3, and then 4, and then 5, and then 6, and then 7, and then 8. Okay, and now let's move into the 0th register the address at the top of the stack, and then branch link to pop the top element, so 8 should be popped out, and then move to the 0th register the contents of the 19th register, and call the print stack function, right? That is what it is called, right? bl print stack. This should print the stack. Let me do this 2 times, here and here, and then after that, almost done. Yeah, nothing else. I don't want to do anything else. What can I do? What should I do? First, get back the value of the 19th register, the original value of the 19th Hey, why the heck do I have branch link to init stack here? Okay, now I will get back, load to register 19th, the value of the stack at the top of the stack, and add to it 16 afterwards, and also load back the value of the frame pointer and the link register, and then and it's from the stack, and add to it 16, and then move to the 0th register 0 and just return. Now, very few chances that this actually works in the first go. Char per, I wrote char per 6. Okay, and the output file should be called out. Let's see if it works. I do not think that it will compile in the first go. There are a lot of errors. Okay, EQ, this, and every place that I used top and air, I'm getting an error. Okay, let's first fix the name of the file, chapter 6.s, and chapter 6.s, and remove these two. Find air, replace air by 4, and then replace this air by 4, and then replace this air by 4. I have no air. Then top, then top, replace this top by well, 0. I don't have to replace it. I can just delete it. Okay, that works. Let's see, clang chapter 6.s, and the output should go to out. Okay, subtract. Okay, those are very valid problems. 96 and 128. Let's go and fix them first. Okay, 90s, line number 96. Yep, and 128. Okay, 19th register should be. I did not give the destination register for them. Now store the contents of this. Just this expected extended store, or this with option shift of 0 or 2. So chapter 6.s. What were the lines that the problem was at? Well, I would suppose, yep, this is one of them. So instead of doing this before, we can add and store to the 4th register the content of this, and the 3rd register, and instead of doing this here, we can do this. Okay, that works. And here also we can do the same. We can add and store to the 5th register the contents of the 0th and the 3rd register, x5, and that should work. Expect to see a lot of errors or nothing at all. Maybe I forgot to return after some of the function. Ah, Yes, at the end of the main function, I am returning. At the end of the init function, I am returning. By God, I am returning. And then why are there a lot of lines? This many lines. Then at the end of the push function, I am returning. Okay, I did not get back these which I stored there after calling malloc. So LDP load back the pointers, the original value of the stack pointer. Why do I keep calling it the stack pointer? The original values of the frame pointer and the link register, and then return. Okay, that is one error solved. Here I'm not calling any external function. Here neither, and I am successfully returning at the end. Oh shit, I went too far down. Here I am not calling any external function, so I can purely return here. Print stack, I am storing these, and then I am getting them back and then returning. Now this should work, I guess. /out. Chapter 6. Okay, this seems to be not working, so let's just print the stack before doing anything. Might just print the stack. 0. Okay, that is good. That is actually good. 0. 0 is a good one. Hey, no. That is different. Chapter 6. Got them back, and what is the thing? I think the print function is working perfectly. The problem seems to be with the push function. It gets the index in the second register and then adds multiplies that by 4. The index multiplies the index by 4. Okay, and then stores that to the third register, then adds 4 to the third register. That is moving past the 4 bytes which store the yes, that is moving past, adding to it the 4, moving past the 4 bytes which store the top of the stack, the index of the stack, and then we add that offset to the 0th register, which contains the base, and store that into the 4th register. Then we store the value of the first register at the 4th at the address at the memory location whose address is now at the 4th register, and then we add 1 to the index and store that at the base of the stack. That also makes sense, and then we return the function. That seems to be correct, but still it is not working. Let me go back and only do the push operations and not anything else. Let's see if it works. Nope. But I do the same, I see the same numbers. Okay, so maybe if I remove some of them, maybe I will see a different set of numbers which I do in some sort. Well, from this I can tell that the stack, the index of the top of the stack is getting updated, but the values are not. Okay, why is that happening? Before calling the push function, I am putting the address in the 0th register and the value that I want to move in the first register. And in the push function, I am getting the index in the 0th register in the second register, and I have the value in the first register. I store it at that offset address. That makes sense. And then I update the index. Maybe the problem is with the print stack function. It could be. 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 Let me print them manually. The address of the string in the 0th register. Uh, Let me get the address of the format string in the 0th register by first getting the page address and then adding to it the page offset. Now in the 0th register, I have the address of the string, and I would like to pass on the in the string that I want to store the digit that I want to print as the second argument to the printf function. For that, I would have to make space at the stack. Ah, shit. Okay. Subtract from the stack pointer 16, and then at the top of the stack, I will store some. First, I will get the address of the base of the stack in the first register from the 19th register, then add on logically shift left. Nope, 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 nope. Okay, I have the address. Now add to the first register. I can manually do this by adding 4. I get the first value, so I can add 4 directly. Yep, and then I can load the value in the first register whose address is in the first register. Okay, after that I will store that value from the first register to the top of the stack and then call the printf function. Okay, that also makes sense. And let me print the second number now by getting the address of the format string again, like that. Oh, I can do this here instead of doing it here. Yeah, and then I will get the string address again, and then move to the first register the address and add to the first register 8 to get the second element, and then load the value from that location and store that at the top of the stack, and then call the printf function. And now fix my amends by adding 16 to the stack pointer, and yeah, that should do it. Oh, why am I being so stupid here? This is very obvious. This is now not how assembly works. I have to provide a destination address, and here also the same, a destination address. And then what do I see? I see the numbers Okay, that is bad. That is actually bad. Let me print the next number in line. Copy this whole thing and just change 4 to 12 to print the next number, and manually Emmanuel, and here change 12 to 16 to print the even next number in the line. And okay, so the printf function, print stack function is working correctly, but the push function is not working. Push function seems to be creating a mess. Is it not calculating the offset correctly or something? Logically shift to mm, logically shift left by 2 means multiplying the number by 4, the binary number by 4. And if it were a decimal number, then it is multiplying it by 100. Here it is multiplying it by 4. And when I do that, when I multiply it by 4, what happens? Okay, I get the index here. Then I multiply that number by 4. Multiply that number by 4, the index, and store it in another register, and this has to be 3. I was being stupid. Okay, so now I do not have to manually push to print all of these things. Okay, push this, and then push a few more numbers. 6, then 7, then 8, then 9, and then I would like to pop. Oh, wait, before pop, I would like to print it once and then pop it. Pop, move to the 0th register, the index, and branch link to pop to test my pop function. Clang /out, and it first it starts from 0, and then goes from 9 till 1, and then it has removed 0 and goes to, but why is it printing 0? I did not add 0 there. Let's push another number, 10. And in the printf function, at the end, I would like to print, just before returning, I would like to print a new line, which is ASCII's \int. Before doing this, I would first get the address of the new line page address, and then add to the 0th address the offset for a new line by doing this page off, and then I can simply call the printf function, and yeah, I can expect it to work fine. ASCII keys, new line, mnemonic, unrecognized, ASCIZ. Oh, dot, it has to be dot as keys. Yes, it works in some way. Why is it printing 0 there? And why is it stuck now? Is it because of this? Do I have to return this in some way or sort? No. Oh, yes, 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 yes. I have to do this before doing all of this. I added 16 here to pass in the arguments to the printf function. Yep, and yep, yep, this should work. Okay, but why is there 0? Is the push function not? It points to an empty value at the top of the stack. So in the print stack, I have to subtract 1. Yep, that 19th register has the index, so I have to subtract 1 from 19. Shit, I am actually stupid. And I have to provide a destination register, of course, a destination register to store the results. And then there was light. Okay. Now I have to re-implement all of this using a linked list, a dynamic linked list, which would be calling malloc again and again to get uh, a new memory location to store the new number, and yeah, that's it. That's crazy. The stack can grow as much. There is a space for it to grow. Chapter not 7, chapter 6. Okay, so the main function does not care about what happens. It is only the other functions, the rest of them. Yeah, the print function also. Nah, the print function does care about what the fuck happens there. So now first, what were the functions? Push. Nope. Init stack. Okay. Let me do init stack. This does not expect any arguments, but it will return a pointer. It will return a pointer to the top of the stack. And for that, it will do a malloc and get, yeah, what will the structure of the stack look like now that we have this? Well, it would have 8 bytes. It would have address of a node that will be the top, and that will take 8 bytes to be stored, and it would take another 4 bytes to store the top, the integer value to store, which stores the top. Okay. So init stack has to get 12 bytes of memory from malloc. Yes. So move into the 0th register 12, 12 bytes, and then with I have to store the the frame pointer and the link register at the top of the stack by pre-incrementing the stack by 16, because here I am calling a function, and a function call changes the contents of the link register, which I will be needing after the function call to get back to where this int stack function was called from. So here, after doing this, I just call the malloc function. I have what I need. Yep. And yes, I have to initialize an array, right? That that would depend on how the push function would work. Push function would initialize an array and store that at the top of the stack. Store that at the top of the stack. Hmm. So it will not, yeah. So the init function does not give an empty node. It does not give an empty node. Yep, that makes sense. After this, I have the address in the 0th register, and I can just return. Yep. Now the push function. Will it call malloc? Yep, it will call malloc. So I will, but before that, I have to load back the contents of the link register and the link register and the frame pointer, and then exit. Okay, and here I will have to do the same. Store the link register and the stack, the frame pointer contents onto the stack, and then after that, what do I do? I would like to have some space. Yep, some space. Yep. For that, I would like to call malloc, and this function has address to the stack in its 0th register. So this function has an address to the stack in its 0th register. Or do I actually need to have a integer which tells me what is the size of the stack? I don't think so. I can just keep moving forward and get address and see if the address is 0, then I know that it does the next for this current node does not point to anything else, and I can just then do this. No, this has ah shit this and an integer value which takes up 4 bytes, and integer value will come first. Okay, it still it takes up 12 bytes, so then it stack function does not change, but the push and other functions too. Okay, in the 0th register, I have the pointer to the stack, and in the first register, I have the value. Want to call malloc, and I want to preserve those addresses, that address and value. So I will store the contents of the 19th and 20th register onto the stack, because these are non-volatile registers, and then move the value from the 0th register in the 19th register from the 0th register, and move the value from the into the 20th register from the first register, and then move into the 0th register 12, because I want 12 bytes of memory for a new node, and I can just call malloc now. Yep. After doing that, after calling malloc, I have a pointer to the new node in whose value field I have to store the value which has been provided to me. So, okay, let's do that. Store the contents of the 20th register, which have the first 20 bytes, the first 32 bytes of the 20th register onto the, let's say, the address which is in the 0th register. So I have stored the value in the new node, and after that, what do I want to do? I want to update the address field of the last node and store the address for the new node there. I can I can do this get final, which will return give me the address for the last node, because this is necessary. I will be using this in push. No, I will not be using this in pop. I will be using this function in top to get that value, but I will not be using it in push, because in push I want to have the value of the address of the second last node, and update its address field, its next field with 0, so that it points to 0. Okay, get final. This expects to have the stack pointer pointed to the first address, pointer to the first address, or like pointer to the first node in the 0th register. Yep. And then this has a loop, or this says recursion. Recursion. It compares. Yep, I would also need to have the address, yeah, of the second last node. Hmm? Do I? Nope, nope, nope. I will not need the address of the second last node. So I can just directly compare the contents of the 0th register with 0, which means I do not point to anywhere, which is actually crazy. Nope, so I do not want to do that. I want to see if the current node points to null. So how do I do that? For that, I have to load the value in the first register from the memory address, whose address is at the is at the 0th register. And yep, so now at this point in the first register, I have the address for the next node, and I am comparing that with 0. Now, if it is equal, then end. Else, if it is not equal, then what do I want to do? I want to get the address. I want to update the 0th register with that new value, with the next node's address, so that I move into the 0th register, the contents of the first register, and what else? I then call the get final function on this next node. This is recursive, and here at the end, it doesn't even matter, and at the end we know that we have the address we need in the 0th register. So we can just simply return, right? We did not mess up with anything else. Nope, seems like it. Okay, this seems good. But what this does is it changes the contents of the 0th register and the first register. So before calling this, I would like to store my stuff somewhere else. What I can do is, what are the things that I am doing in the 0th register? The only important thing that is not saved is at this point the address that is stored in the address to the new node that is stored in the 0th register. I can move that into the 3rd register, which is not touched by the get final function, and then I can branch link the get get final get final function. I can branch link to that, and I can expect to have the address of the address of the last node in the 0th register. And now I would like to update that address with the address that is stored in the 3rd register. Uh, the last node's address, I have to update the last node's address field, the next field of the last node, with the address of this new node. For that, I have to simply do store the contents of the 3rd register, which contain the pointer to the new node, at the 0th register plus an offset of 4. Yep, plus an offset of 4. And at this point, we have successfully stored the value that is provided to us and successfully added the new node to the linked list. And yeah, that makes sense. You've done it. But what if we get 0 every? What if this is the first node? That is also a question. What if this is the first node? What would happen if this is the first node? If this is the first node, then the get final function, this will do malloc, will give me a new node, and that new node's address will be stored in the address field. Yeah, that should not happen. That should not happen because the init function is giving me a pointer to something. So do I want to initialize that with something? The top of the stack, can it? I want to store the first value. Okay, the push function can check for it. Here I have the address and uh, the address. Yep. So let me, before calling malloc or anything, let me load the address. Load the address that is stored in the node that is provided to me. And how do I do that? I will get the address in, let's say, the 3rd register, x3, and where is the address? The address is at x0 plus an offset of 4. And then after getting the address, I compare that with compare that with 0. and branch if they are equal. I know that I have got the first node, then I can simply branch to the to first. Here I can create a function called first, which handles that case. What is the case? It handles the case when it is first. That is, it will store the contents of the first register, mhm, the contents of the first register at the address of the 0th register. Okay, and yeah, will it give a new node? Nope, it will not add a new node. It will simply do that, and yep, add it, and yeah, that makes sense. It will add it will put the value in the first node, and what if after that I call the push function again, which I will, of course, then the get final function, what will it give me? It will give me the address of the first node itself and nothing else, and I will store there the next node. Okay, that is okay, that is okay. Now after that I need to fix the things that I did. First of all, load back the value of the 19th and the 20th register from the stack, 16, and the contents of the frame pointer and the link register also from the stack, and then I can just return. And in case of this, after storing the new node, I can just does this function return anything? Nope. So I will just do the same that I did here. We'll do the same thing here at the end and move to the 0th register 0 and return with that. Take that. Okay. Yes. Ah, yes, I can push values onto the stack. Yes, I can. Yeah, I can push values onto the stack. I can get the final value. I can end. Yep. Now comes what? Pop. Push pop. Yep. Pop. This gets an address to the top of the stack. This will not be calling any function. This only has to get the address of the final -1. So this will make its own loop. First of all, I will compare the address. Now, I will, yeah, let me compare the value for, let me get the address for the next node. Yep, and get the address for the next node. For that, I load into the first register the value that is stored at the 0th register plus an offset of 4. Now I have the address of the next node in the first register and the address of the current node in the 0th register. Now I compare if the contents of the 0th register with 0, and if it is equal, then I know that I am at the first node. This is the first node which has not been initialized. I am at the first node which has not been initialized. I can do first pop. What does this do? First pop. Yep, I can directly do that without any problem. First pop, what does this do? This makes the value move. I will already have 0 in the first register. So I can store the value 0 from the first register at the memory location 0. So that is just erasing that, and yes, this should do it. This line just erases the value that is stored in the first node if there is any value, and does this. Okay, and now if it is not, that is I have a string of nodes. What do? I need to find the second last node and update its next with 0. Then I start a loop, right? Yep. Then I start a loop. Loop to find um, um, second last. This will find the second last thing, and this will be a post increment loop. What will this do? This will first of all update the 0th register with the contents of the first, because the first register at this point has the address for the next node, and store into the first register the address, the next field of this new next node. Now I have that. Then I compare that with 0. Yes. No, I do not want to do that. I also want to preserve the original value at the 0th register. So before doing this, I move the contents of the 0th register on into the third register, or let's say the second register. Right. Then I compare these, and then if it is um, if the 0th register, if the first register is greater than 0, the contents of the first register are greater than 0, then go back to the second last, and what will happen in the 0th register? I have the address for the current node. I move that to the second register, and then I update the contents of the 0th register with the address of the next node, and then I update the contents of the first register with the next node, and I check that if it is 0, and if it is not 0, then I know that there is another node. So therefore I update the second register with the contents of the next node. Yeah, that makes sense. Now I know that when I get to this point, then the node uh, whose address is in the second register is the second last node. So I have to store, first I will move into the, let's say, first register 0, and I will store 0 into in the address field of the second last node. The second last node is in the second register, and the offset is 0, 4. Okay, and then I can simply return, right? That is the pop function. That is the pop function. That is how it will work. Now, is that correct? Yep, that seems to be correct. Yeah. Do I have to free what I did before? Yeah, free, because I used malloc. God damn it. Mm, it is okay. A segmentation fault or memory leakage, that is okay. Now I have implemented pop, and now I need to implement top and then print stack. Let's do print stack first. In print stack, how is it going? It's good. Yep, I am in the middle. In the print stack, print stack function expects to have zero, expects to have the address of a node in the zeroth register and then work from there. And I would be needing some, I would be calling functions, so I will store the frame pointer and the link register onto the stack by pre-incrementing the stack, and I will also be needing some extra non-volatile registers, that is register 20 and 19. So let me store them also in the stack, and then I will also need some space on the stack. So let me get 16 bytes on the stack because I want to pass arguments to the printf function. Now I will see. I want to see if the current node is first or not. Yeah, I can actually do this. I can make a print function which gets, first I will store move the address, move into the 19th. Wait, what? I do not need the base address again and again. So yeah, I do not need the base address again and again. I want, I will get the, no. What do I want? Yes, I will be needing them. This, these. So first I will store, shit. At this point, I would expect to have in the 19th register the current address. So let's do that. Move into the 19th register the current address, which is currently the base address. And then I can successfully first print the first value and then check, update the current address with the next address. Okay, for print, I need to get the format strings address in the 0th register. For that, first I will get the page address on the format string like this, and then add to it the offset format page offset. Okay, I have first thing, and then I want to have the value of the current address in the, let's have it in the 0th register. Store in the 0th, not store, load in the first register the value whose address is in the 19th register. 19th register points to the current node. Okay, now I have that. Let's store that value onto the stack. Yep. And before calling the printf function, yeah, I can just call the printf function now. bl printf. Now I want the current node to point to the next node. For that, let me get the address in the 0th register. Um, Load into the 0th register the address of the current node, which is this, the base address plus an offset of 4. And after that, make move into the 19th register the new node's address. And now I would like to compare the 19th register contents with 0, that is the address for this new node, and if it is 0, then branch. If the contents of the 19th register are greater than 0, branch to where? Branch to the print function. I hope this actually works. I hope this works. Right, this will keep printing and printing and printing. After that, what do I want? I want to print. I want to print a new line and get the address page in the 0th page address for the NL label, and add to the 0th register the offset for that, and then just branch link to print f function. And after that, I will fix the stack by first of all adding, no, adding required. Yes, adding required. I did subtract something from the stack, right? Wait. I'm calling the printf function without. Yes, I am storing something at this. Yes, I did subtract something from the stack. I subtracted 16. So after that, I will subtract 16, add 16 to the stack pointer like that, and load the contents of the original contents of the 19th and the 20th register from the stack, and after that add an offset of 16, and then load back the contents of the frame pointer and the link register from the stack and add 16 to it, and then I can just return with the exit code on 0. This should run. Okay. Okay, load. Okay, load. Oh, shit, it's the same thing again and again. And chapter 6, line number 167. 167. This should be load pair. This should also be load pair. This should be load pair. This should be load pair. Init stack from the main function, but the init function does not exist. That is init stack. What is the next init stack? Shit, I did not create the init stack. What the heck? What did I do before here? Int stack. Oh, my bad. Init stack. Nope. Okay. First, I will take a little break and go to the washroom, and then me back. Yes, we are seeing some problem here. We see 10 and then we see 0. Why is that? Chapter 6. And what are we doing? What are the things we are doing here? Okay, we did not. Oh, we did initialize. What happened? I heard something. Streaming good? Yes, streaming is good. Yes, we first initialized the stack, then we moved it that value somewhere else, and we did our stuff. Hmm, 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 hmm. We have been pushing values to the stack. We did push the value 10. So does the fault lie where? I think it might be with the push function. Let's see the push function. The push function, what does it do? First of all, it stores the stack pointer and the link register and the other thing onto the stack, and then these two, and then moves the base address in the 19th register and the integer value in the 20th register, and then it loads the address of the next one in the third register, compares it with 0. If it is equal to 0, then it goes to the first, that is it. This is the first node, and if it is the first node, then it stores the value of the first register of the integer that was passed on into that node, and then gets back the things that it used and then returns. Okay, that is cool, that works. And then in the second iteration, if I push something else, then it first of all moves these in the 19th and the 20th register, bypasses this because this, god damn it, I'm getting the address for the next one here in the third register. Mm. Shit. I am getting the address of the next one here in the third register. That ain't cool. That is not cool. Okay, now here, before doing this, I have to get the value stored in that node. For that, I do this load into the let's say second, yep, into the second register the value of the first. So I get the value of the first node here, and then I compare that with 0, and if it is 0, then I move on with what I was doing. But if it is not 0, then I will have to start from here, right, by mallocing something, and this should work then. So for that, I am giving this a label which is not first, and I compare this, and if branch, if greater than, if the second is greater than, that is not greater than, but if there is like The value in the first node is not equal, not negative, no, not equal, then we branch to not first. That should work. Okay, that should work. That did not. B and E does not mean anything. Okay. Sorry, let me move this code to the top. This code here and push. Yep, not equal, not first. What the heck? Not first, and here. Yes, not first. That works. And what was the thing? This. So if it is, how do I check for not equal? Branch when um flag bits not equal in AArch64. B and E, that is what I have. Oh, NE, replace that with E. NE is not equal, not negative. Oh, chat, okay. Ah, shit, I went to another register, uh, into another folder. So, lang cd assembly and book and clang this. Hopefully it works. Seems like the printf function is now misbehaving. Let's see, not the printf function, but this print stack. Here I am storing the link register and the frame register onto the stack, then getting some volatile registers to work with, and then getting some extra space on the stack. And then I am moving the current address into the 19th register. Okay, and then in the print statement, this is what I do. This is all that I do. Okay, what do I do? In the print thing, I get the format string address in the 0th register and the value of the current node in the first register. Supposing that the 19th register has the address for the current node, I get that and then I store that onto the stack and then I call the printf function. That is perfectly good. Then I load the next address in the 0th register, move that into the 19th register and compare that with 0. If it is greater, if the contents of the 19th register are greater than 0, I go back to the printf function. Otherwise, I print a new line. And I seem to be printing a new line. Why? Why am I on just printing a new line? Is there a problem with the push with the push function when I am inserting my second value? Let's suppose that I am inserting my second value and here I come, and at this point what do I have? I have that in the 19th register I have the base address which has a value but does not point to anything else, and in the 20th register I have the value that is to be pushed onto the stack. Now here I get the address for a new node in the 0th register, then I store the value that was given to me into that new node, and then I move into the third register the address of this new node, and I call the get final function. And here is the get final function. What does this do? This function get final loads the address. Wait, what does this get final function expect? It expects to have shit, god damn it. Before calling the get final function, here I have to move into the 0th register, the base address from the 19th register, and then call the get final function. Hopefully this works. It does, but it also messes up stuff. Okay, why? Yeah, the problem was with printf function, right? Right. It's after calling the first printf. Is there something that I do? After calling the first printf, yes, there is something that I do. I pop. No, I pop. Yep, I pop. Pop UPI. I pop. And what does pop do? Pop finds the second last and does something with it. So I get the value for the next one I get the value of the next string in the first register and compare it with equal, and if it is equal then I branch to the first pop function, and there I store w1 that is 0 in at the value for this node, and then I return. Okay, that is very valid, very valid. And in the second last function, if the current node is not the last node, the first node is not the last node, I want to find the second last node, for which I move the current node in the second register, and then I move the index of the next address of the next node in the 0th register, and then I get the address of the next node in the first register. I compare that with 0, and if it is uh, greater than 0, that is the next node is not the last node, then I run this function again. But if it is the last node, the next node is the last node, then I move 0 to 1, and I move 0 to the current node's address because the next node is the last node. Huh. So pop is good. Pop is good. Let's um, call this, just call this like that, removing the pop, and call the function print function again. Okay. Okay. We only did this. We called a pop, and that was the only thing we did. Okay. Dot slash out. Okay, why is it getting stuck? Why the fuck is that happening? What is it that the pop function is doing which it should not do? Is it accessing some non-volatile registers? Pop, its only function revolves around 0, 1, 2, 3 registers. 0, 1, and 2 registers. So that is not the problem. It does Nope, that is not the problem. Mhm. What is this doing wrong? When I know the next node is last, then at that point I am updating the address of the current node with 0. Yeah, that should not cause any problem. And if it does cause any problem, then that problem would become apparent after printing up to that last node and not at the first node. This is causing a problem at the first node. And why is that? 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 Why is this happening? What is the problem here? The pop function works fine. First pop also works just fine. It is not even doing any function calls, not updating the link register or anything. It is branching properly. Is it because it is branching using EQ and all that stuff and not storing? Just let's just see that. Store the frame pointer and the link register onto the stack by pre-incrementing it by 16. I think when I'm using BEQ and BGT, then these things, the link register is automatically getting updated. So store the store back, load and load the frame pointer and the link register back from the stack, Yep, and do this and then return. And here also, then return. This might be it. Not slash out. This might be it. It is not it. Okay. And I thought that might be it. Here. I'm storing these. Then I am retrieving them properly, loading them, and then returning. I'm not messing up with the stack. Not in any way or form. Store, load, load. And why is the problem happening at the first pop? Yeah. Branch if equal. That is the next for the that is if the address that is stored in the first that is the address that is stored in the first nodes node is 0, then I know that it is the first node that I need to pop, and I do this. But if it is not, then I do this, all this. But what is the problem? What is the goddamn problem here? Second to last. Is it the way that I'm comparing these? First greater than, okay, but comparing and branching when greater than is the same thing that the get final function uses. Well, it uses dot end. So I want to see if it is not Then last one, I can do not equal. That also works, I guess. Clang. That does not work. I would like to see what is causing this. After this, let me do something like this. I will have, let's say, test string, which is as keys format and says hello there with a new line at the end, of course, a new line at the end. And after that, I would like to print it here between here, like here, by getting the address in the 0th register. For that, I have to get the address of the page into the 0th register for test, and then add to that the test page offset, and then call the printf function with that, and do the same thing here after the pop. Let's see how many tests do I see. So I'm getting stuck in the pop function. That is a very useful hint. Ah, I'm getting stuck in the pop function. Okay, here in the pop function, this is the place where I am getting stuck. Why? And where are the branches happening? In the pop function, I only branch at this point, and if I branch at this point, then it just ends. But when I'm here, and then this might cause an infinite loop. This might cause an infinite loop. But why is it causing an infinite loop? I am comparing the contents of 1 with 0, and if they are not equal, then I'm going up. So are they never? Is the address and the first register not equal? So shit, whenever I initialize an array in the pop function, I need to give it 0 values, I suppose, in the push function, and I'm getting things by malloc like that. So let me use in put. No, not yes. Even in the initial function, I would have to do that. Move in the first register. In the first register 0. There is a register for that line, 0 register. But anyways, and then store. Yes, store the first 32 bytes from the first register at the new node's value, and also store 0 at the address part of that. And I would like to do the same with the push function before putting in any values. After getting malloc, yep. After getting malloc, this is what I should do. Yep, this might work. Hello there. I'm getting stuck in the pop function. right? I am getting stuck in the pop function, right? Yep. This printf works, and then I call the pop function with the current address, and then the printf does not work. So I'm getting stuck in the pop function. What the heck is that? Why is that happening? Big. Okay, why am I getting stuck in this pop function? It is definitely happening because of this branch instruction. This is not ending, and this is branching every time. But why is it branching every time? Why the heck is that happening? Hmm. Hmm. Why is that happening? Why is it branching every single time? Branch when not equal, when the contents of the first register are not equal to 0, then branch back here and update the contents of the first register to its next register, to the address that is stored in its next part. Mm, mm, Let me, instead of checking for the address, mm, 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 I have to work with. Wait, yes, the address can be 0 when it is not pointing to anything else. It can be 0. Oh, shit. Instead of loading, I'm doing store. That was the problem. That was the problem. Instead of loading, I was doing store. Stupid. Okay, now we have completed all these questions, and only question number 11 is the one that remains. And we have completed the 2 hours mark. Let's move on and complete this. 2 hours and 3 minutes. That is cool. And I suppose the streaming quality is also good. I am live and stuff. Stream number 22. That is crazy and challenge. Hehe. That is for me to see, not for you. The Software Engineering Code of Ethics and Professional Practice states that a responsible software engineer should approve software only if they have well-founded belief that it is safe, meet specifications, passes appropriate tests, and sub-principle 1.03, and ensure adequate testing, debugging, and review of software on which they work. Okay, sub-principle 3.10. Okay. Unfortunately, defects did make their way into the system. The Software Engineering Code of the Ethics also states that a responsible software engineer should treat all forms of software maintenance with the same professionalism as new development. Okay, explain how the Software Engineering Code of Ethics and professional practice were violated by the Thrack 25 developers. Well, there was only one developer working in assembly language to write the software. But the thing is that they were not careful. There were mistakes made, and the safeguards were moved from the hardware to the software, but those software safeguards were not tested adequately, and the hardware and software were designed separately and then assembled at the endpoint and then shipped to the customer without any testing. That was bad. How should the engineers and managers at AECL have responded when problems were reported? Well, they should have taken adequate responses. I don't know why the heck I'm even doing this question, but they should have taken adequate responses when they heard that their machine is causing some problem. Then they should have spent more time and taken it seriously and sent engineers to see what the actual problem is instead of telling the people to remove some keys from the keyboard. See what other ethical and non-ethical considerations may have contributed to the deaths and and injuries. But if the machine is being used to save life, and if the cost of error is injury or death, then you should treat the craft that you are making more seriously, because injury and death are real. People feel real pain. You cannot unsee it. You cannot ignore it. People actually have feel pain. You have to take them more seriously and ethical and non-ethical considerations. Well, as a software engineer, you have to be ethically mature if the code that you are writing is being used in some serious space, because that can of course cause death and injuries, and your code is being used by actual real people. You are not just messing around as a scientist to see how things work. You have to have professionalism and perfectionism to make the best code that you can without bugs. And if you are not sure if your code, if your program can be trusted, then you should not release it. Even if your boss tells you and gives you a deadline, you should not do it. That's it. Completed chapter 6. Now, integer mathematics. And what is the time? It is 2:08. We can do something here. Okay, examples. Example 11, that is crazy. That the first example is example 11. That is actually crazy. Okay, we can do these two pages at least. Integer mathematics, chapter number 7. Integer mathematics, chapter 7. There are some differences between the way calculations are performed in computer versus the way most of us were taught as children. The first difference is that calculations are performed in binary instead of base 10. Another difference is that the computer is limited to a fixed number of binary digits, which raises the possibility of having a result that is too large to fit in the number of bits available. That makes sense. This occurrence is referred to as stack overflow. Overflow, not stack overflow. Or stack overflow is different. The third difference is that subtraction is performed using complement addition. That is, we find the two's complement of the number whose value we want to subtract and add that to the number from which we want to subtract. Addition in base B is binary, is very similar to base 10, except that the result of each column is limited to B minus 1. B is anything. For example, binary works exactly the same as addition, decimal addition, except that the result of each column is limited to 0 or 1. The following figure shows an addition in base 10 and the equivalent addition in base 2. This base 10, this base 2. The carry from one column to the next is shown as a small number above the column that is being carried into. Note that carries from one column to the next are done the same way in either base. The only difference is that there are more columns in base 2 because it takes more binary digits to represent a number than it does in decimal. We have a lot more vocabulary in decimal compared to binary. Then subtraction by addition. Finding the complement was explained in section something. Subtraction can be computed by adding the radix complement. Radix, okay, 2's complement if it is base 2 and 3's complement if it is base 3 and 10's complement if it is base 10. That is crazy. Complement of the subtrahend to menu and example 11 shows a complement subtraction with positive results when the menu end is less than the subtrahend. Menu end is less than the subtrahend, the result will be negative. In the complement method, we deal with this possibility by adding a sign bit at the beginning of the number. Example 12 shows complement subtraction with negative result. Example 13 shows several more signed addition and subtraction operation in base 10 and binary. Base 10's complement subtraction, that is crazy. Okay, for this, we get this. The complement for 56 when we are using 4 digits to represent a number is this, and that is just a 10,000, right? Yep, 10,000 minus 56. That is crazy. Complement, tens complement, not two's complement, but tens complement. Suppose we wish to calculate this minus this using the complements method. We first pad the, but how the heck does it work? Why does it work? If I add this number to 10,000, then I would get 10,000 this number. But if I find the complement, wait, and if I want to subtract this from this, I get this. But after subtracting this from 10,000 and I then add this to 10,000, I would get this number minus this number. That is this. And we can discard the first bit. That makes sense. That makes sense. Tens complement subtraction with a negative result. Suppose we want to calculate this minus this. First, we pad leading. Okay, so this is just this, and if we are using 4 digits to represent our number, then we have to add this to 9,519. 9,519. Add this to this, and we will get this number. Then I can just. The answer is the first digit is greater than 4, indicating that the result is negative. Therefore, we take tens complement of the result to get this. Okay, so we have to take tens complement, that is subtract this from 10,000, right? Yes, and put a minus sign before. And then signed addition and subtraction in decimal and binary. This. Addition and subtraction. Now, binary multiplication. That is a long thing. What will be our target for tomorrow? Well, of course, completing the binary multiplication part, which has a lot of reading, 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 reading. Then we have binary division, which also has a lot of reading. And this is good because my concept for binary multiplication and division is not as clear as I would like it to be, as I would be comfortable with. So Shit, it would be difficult to complete them both, multiplication and division, in the same day. And then we have big integer abstract data type, which is a goddamn big ass C function. What the heck is that? Am I mistaken in some way? Nope. So this smaller function is 200 lines, and this larger is 700 lines. That is a big ass function. Okay, after that, that is, we write some code in assembly. Okay, and then we have questions. How many days will it take us to complete this chapter? 1 day for multiplication, let's say. 1 day for division, let's say that. Okay, and then 1 day for abstract data types, big integer abstract data types, and hopefully the day that we begin this, we can end this, do this. We are of course not going to read this whole 700 line C code because that is not the thing. And we can, yes, we can complete this chapter easily, and then we can get on with the exercises. Multiply this by this using 8 5-bit multiplication to form a 16-bit. Show the result. Show all of your work. Show all of your work. Like manually multiply. That would be okay. So I'm guessing 3 days. This, like tomorrow, day after tomorrow, and the day next. That is 10th, 11th, and 12th of February. We will complete this chapter and move on to the next. What the heck? Let's move on to non-integral mathematics. So the rest of this book seems to be dealing with binary things, which would help us, reading this book. And I don't know if I will be reading this book on stream. I don't think so because I have a physical copy, and how do I read a physical copy on a stream? No, so this is for me. I will not be reading this book on a stream, and okay, that is good. That is it for today. Thank you, and god damn it, how long have you been stuck on this screen? When I was working on print stack, shit, god damn it, you were not able to see my screen. Shit. Shit, my stream has been stuck for how long? Shit, it has been stuck for half the time that I have been streaming. Shit, it has been stuck from the start. It has been stuck from the start, from the first question. That is very bad. My stream has been stuck from it got stuck 1 hour and 57 minutes ago. Shit. I apologize. Shit. Shit. Ah, shit. My bad. Yeah, but that is the end of the stream, and shit. There is nothing I can do about it. Right.